I think the agenda for today is we'll be solving few coding problems which we typically see in top tech companies. The okay, I'll just let you know the format here. So what I'll do, I'll write a problem statement and maybe give a minute to you so that you can just think around. Maybe if you have copy pen around, you'll just try to figure out the solution that you have in your mind, and then I'll go iteratively, like what could be the most brute force solution, and from brute force we'll try to move towards a better solution. And again, like I emphasize on this way too much, but it's true. Like it's okay if in an interview you are not getting the perfect solution in the first attempt. You can move iteratively towards that as long as you are moving forward and taking cues from the interviewer. So yeah, I think I'll get started with the problems. So in case you have any issues, I would recommend picking it on the chat, or even if you want to directly ask me here, I'll be more than happy. And if you think I'm going too fast, just ask me to pause me. I'll be more than happy to again write the solution for this. So yeah, I think the first problem we're going to solve today is, let's consider an array and it has at least three elements. Let the array be something like this: 1, 2, 4, 5, 3, 6, 7. We have to find out if there exists three indices I, j, and k such that value of array of I, j, and k is in increasing order. Something like this: 2, 5, and 6. This is a triplet which is in increasing order in this array. So we have to return true for this. So this would be the input, and we would return output would be true for it because we have at least one pair. So I think the problem is not at this point of trying to figure out what that pair is, but just do we have a pair that satisfies this particular equation, this particular rule. And I would want you guys to just think about what approach you have, maybe for a minute, and then uh, I'll tell what could be multiple approaches, and if you have any questions, then we can move forward. Again, yeah, I'll be monitoring the chat, so if any questions are there, uh, just feel free to pick on chat. So yeah, I think I'll go with, I think what we usually do. I think this is something I try to follow this approach. Like whenever you get a question, even this might not be of that high complexity, but when you get a question and you don't know what to do, the first thing is just perform all the steps that are being asked. That what we usually say is a brute force solution. So here, what we're going to do is we look at the input array and we look into all possible triplets and say, hey, are all these three in increasing order or not? If yes, we return true. That's a fairly simple solution. And I just quickly write down the code for this. Oops, it should be I plus 1 so that we don't. K j plus 1. K is less than n and k plus plus. Where INTN is equal to ARR dot size. Basically, what we do here is, and we say, hey, if ARR of I is less than ARR of J is less than ARR of K, Basically we have figured out triplet that follows this rule. What we say here, we just return true here. We return true. And if there is no such scenario where this pattern is being followed, where these three numbers are in increasing order, we simply return false. So we can encapsulate this one in a function. And if you see, like, this is a pretty much simpler, this is a pretty simple solution that we have written here. And if you look at the complexity, I think the complexity is one of the most critical part. This is NQ. For each array, we are trying to traverse this 3 times. For corresponding to not 3 times, we are trying to figure out all the 3 triplets. That means corresponding to each element here, we have to iterate through all the combinations of 2s, and we know like we can get that n square combinations. So corresponding to that, for each of the numbers, it tends to NQ. I think this is the okay-ish first solution. Like I won't say like this is the perfect solution or we should stop here. The first step, I think that comes here in my mind is, okay, this is something we have done fairly easily. Do we actually need to traverse it 3 times? Like, is there a way I can figure out? So just look at these numbers. So it's only a triplet. We don't have to find an increasing sequence. So basically, if I look at the middle element, I'd say, hey, for every element, if I find out, let's say it's 5 here, if I find out there is an element smaller than 5 to the left of it, and there is an element smaller than greater than 5 to the right of it, can I be able to solve this? And that's what we are doing essentially. So what we can do is, for each element, we figure out, is there a smaller element to the left of it, and is there a smaller element to the right of it? The best how this helps is, now we don't have to traverse in n to the power 3. Instead, for each element, we just have to traverse the whole array once, which basically trims down it to n square. And this is, and I think there are ways which we can even decrease this complexity. But I think, yeah, let's go with the second solution. This is the solution one we had where we did, hey, let's do everything brute force. But I'm going to do solution 2. Solution 2 again says the same thing. And is again the ARR size. And then what I'm going to do is, okay, let me put it in the next window. Next, this will be easier. So what I do is, I am again trying to traverse through the array, check all the elements to the left and see if there is an element smaller than current number. So what we have to do is, hey, I think the trickier part here is we don't need to start from 0 because we're looking at the middlemost element. So we are okay to start with the first index. So what we do, we say, hey, j is equal to 0, j is less than I minus 1. It's okay, we do equal to j plus plus if ARR of j is, if ARR of j is less than ARR of I, this eventually means there is a smaller number, there is a number smaller than the current number. And what we can do is we can keep a boolean is smaller, which is false initially. And what we do is we say, hey, there is a smaller number, and we make it true. And then we break this through because you only need to find one number which is smaller than this. Okay. And then what we say is, hey, if there is a number which is smaller, or we can say, hey, if smaller is equal to false, then we can continue our for loop. Why? Because there is, for that particular index, there is no smaller element to the left of it. And then what we say is, hey, so if we go past this, that means there is a smaller number. Then what we do, we try to traverse the rightmost array, which is, I'll keep it j itself. There's no issues. I plus 1, j is less than n, j plus plus, and something very simple. And again, like we'll do something similar. bool is larger. It is initially equal to false. And what we're going to do is we're going to do it true and again break this loop. And then what we're going to say is if is larger is equal to true, that eventually means we finally have a number which is greater than the current number to the right of it. And that eventually means we have a number, and so basically we have got a triplet, because if we reach this part of the code, we already know there is a smaller number than that to the left, and now we have figured out there is a larger number at the right. So what we do, we just return true. And if there is no such case, we return false. So if you see, what we have done here is we have tried to remove one, like we have moved from O of n cube to O of n square. So this is what we have done. We have moved from O of n cube to O of n square. And but I think the next step here again comes, like, is there a way like we can, so whenever you face such issue, when you are trying to move from n cube to n square or n cube to n, you try to see, is there a way I can do a trade-off between time and space? So sometimes what we can do is, instead of n square in space or time, we can say, hey, is there a way I can do this in n of time, but I'm okay if to use a space of n. So this is a very interesting problem that you can ask your interviewer, saying, hey, I know a way. Let's look at the third way we can solve this problem. What we can do is, imagine alongside this array, which was something this, we build a min prefix array, which is nothing but storing but the minimum elements till now. So first element minimum is 1. For second, it's still going to be 1. And I think I'll not start with 1. Instead, I'll start with 6. Initially, it is 6, and then it is 2, 4, 5, 3, 6, and 7. Oh, sorry, my bad. It's the minimum element is going to be 2. And what I do, I also figure out the maximum element from the right. Like, the definition of minimum element is starting from left, what is a minimum element, and now let's say starting from right, what is the maximum element. So here, if you can see, it's going to be 7 here, 7. Yeah, it's going to be pretty much 7. And so I think what now we have is, and to find the minimum numbers and maximum numbers, this we can do in O of n. So this whole operation can be done in O of n. Correct? And this also operation can be done in O of n. So by traversing array twice, we can create this array, which will again take a space of O of n. It's just a trade-off that we have done. But now what we know is, for every number, we know which is the smallest number to the left of it and which is the largest number to the right of it. And if there is any number which has a smaller number to the left of it and larger number to the right of it, we already know that's a triplet, and we just return 1. Again, like, if you see the complexity of this code, it comes out to be O of n only, because we are just iterating it 3 times. We can optimize it for iterating it 2 times also, but worst case, let's say we do min-max in 2 separate arrays. We can do it single also. Let's say if we do it separate arrays, so we'll have to iterate 3 times. 2 times to get the minimum and maximum, and once to figure out which element it is. But the con is, we have added a space complexity of O of n here. But again, just letting you guys know, if there are multiple arrays of size n and it's like constant into n, we still treat that as n. And but if this n again, like, if that constant also tends to n, the complexity becomes n square. Yeah, so I think we started from a brute force n cube solution, we went to n square, and now we are reached a space where we are saying, hey, we can do this question in time, space O of n and space O of n. But the trick here is there a way to not even use this space? And that's it. The interview will try to give you a hint that we don't need the order here. We don't need any sort of order. We just want to figure out if any element is there that has a smaller number to the left of it and larger number to the right of it. Also, that can also mean for any number 5, there are two numbers which are less than that number. And if we continue, so I think these are the hints, cues we have to take. So I think I'll show you the third approach that we can come up with. I think the approach simply says, imagine if we keep track of the max two numbers at any point in time, the max two numbers. So let's say we have max 1 and max 2. So at any point of time, these two numbers will denote the maximum two numbers. We'll start initialize them with int min. So we'll initialize them with int min. Okay. And then what we'll do, let's say the same array 6, 2, 4, 5, 3, 6, 7. At each step, we'll update these values. And at any point, if we find out that our max 1, we already have a max 1 number, we already have a max 2 number, and we find out a number which is greater than max 2, that means we definitely have a triplet and we don't need to store any of that. I'll just quickly write the code and then we'll do a small dry run of this. Yeah, I think I'll write the pseudo code here first. So basically what we have to do is at any point of time, we just have to figure out, I think in the interest of time, I'll just try to write the pseudo code here. Whenever we get a new number, we just update what is the first maximum number at that point in time. And then what we update the second max number as soon as we get a number greater than that. So let's say we get 6 initially. Initially 6, we get, I'll just write here what max 1 and max 2 will be. We get 6 initially, max 1 is 6. After that, we get 2. So we update the values, max 1 becomes 2 and max 2 becomes 6. Then we get a number 4. Now 4 is greater than 2, definitely. So what we do, we update the value of 2 to 4. And then we are saying, hey, we got a number 5. Oh, 5 again, we'll update the value 5. And then we get a number 3. 3 is less than both of these, we do nothing. And then we get a number 6, which is equal to, we do nothing. And then we get a number 7. This number 7 is greater than both 5 and 6. And this is when we actually realize, hey, that means there are two numbers less than 7 which are occurring to the left of it. And that means we have that triplet. And one of the most confusing points here, but like this confuses a lot, because what we are saying is we are not sure about the order of 5 and 6. We are only saying 5 and 6 occur before 7. But if you look how we are trying to update max 1 and max 2, that means even if there are two only cases, either it's something like this, dot, 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 there is a 5, then there is a dot, 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 6, and there is a dot, 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 and 7. So we know this triplet is correct. Second case is there is something like this, dot, 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 6, dot, 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 5, and then we have 7. So what we know in this case is that if max 2 is 6, there is a number smaller than 5 that is before 6, whose value 5 has taken. And in such a way, like we don't need to even traverse this whole, we don't need to store any data. And all we need to is just traverse this array once and we'll get this answer in O of it. And I think this is what's critical. Like in an interview, if you start from this, like I know this is fairly brute force. It's okay to start from a brute force approach and quickly move towards a better solution. And I think that's how you should be looking into any problem you guys face. And from an interviewer's perspective, I think the data points that we usually look at are how quickly are you able to implement the code, how quickly are you able to, how strong, if we are giving very hit, how quickly are you able to reciprocate to that. So I think we need to look into these things. So yeah, I think we'll move on to problem two. Yeah, I think problem two is something simple. Imagine we have a 2D array of a binary 2D array. Binary 2D array means simply an array with zeros and ones, something like this. And it's filled with zeros and ones. So what we're trying to define is an island. So island is nothing but a cluster of ones. So basically, what does one denote here? One's nothing but it denotes a land. So imagine one as a land and zero as a water. And the problem is fairly straightforward. We have to find out the number of islands this particular structure has. So if you look, this whole the first column in all these contain one, they form a single island. So if you look, I'm just highlighting the ones. So basically what I'll do is I'll highlight the ones here. All the elements in the first row, first column, as well as the second column, second row. This all forms a single island. And similarly, we have other cluster. This is an isolated island, and these two are part of another island. These two again are part of an island. So the problem is something fairly simple. Given this 2D array, find out how many isolated islands there are. I think you'll see this problem so many times and different variants of it. So we'll start with the base problem that says, hey, tell us how can we find out the like number of islands. And like I'll pause for a minute so you guys can think about the solution for some time, and then I'll go towards writing the code. Yeah, I think I'll start with the solution. So I think the solution is something like this. If you look at this looks like a graph problem, and like these are like you just have to figure out what these corrected components are. But I think what you could reiterate with your interviewer is how these islands are connected to each other. There are two variants of it. Sometimes we say only adjacent ones should be considered part of a single island. So what I'm trying to say is something like ones which have a common boundary. These all are part of a single island. But let's say if two ones are diagonally associated with each other, they don't form a single island. They are part of different islands. This is something we usually discuss with the interviewer, and there won't be any code changes because of that. It's just instead of 4 directions, you'll have to look into 8 different directions. And again, like I think the if you look at this problem, like the first thing that comes to our mind is, hey, if you are able to somehow figure out uh, connected components starting from any one. So let's say I start from this one, and I say, is there a way I can traverse all the connected components, and maybe and I'll add a counter saying, hey, I have updated it once. But the issue arises, what happens if you again receive a one? Let's say there was another one here. Now, what you initially in the first step, what we could have done is say we could have started from this one, applied any sort of traverse. It could have been BFS, it could have been DFS, and then they both of them like we don't see any major pros and cons in these sort of problems for those. So what we do is we update or we find out, hey, this is a cluster of ones, and update our current count to one. Then we reach the second element, hey, this is again one. So it's important to keep track of what islands, parts of islands they've already traversed. So multiple approaches are there. First of all, what we can do is instead of while we're iterating, we just copy paste this. Yeah, while we are iterating, instead of keeping it one, we update its value to two. Okay, so while you are iterating, you know, hey, I don't want to change it. Like we already have a two value. So next time when you get a two, you already know, hey, this is traversed. This could be any placeholder minus one. It could be zero also. But this is something you have to be very open with your interviewers. Like, do you, because in some cases what happens is they don't want to process or they don't want you to update the data structure they have provided because they might want to perform some other operation on this. So what you have to ensure is just ask these questions if I can update. If you can update, you just update the values to ensure that, hey, you don't traverse those paths all over again. And I think something similar, like as soon as we reach this one, we can update this to two again, or maybe any other placeholder and say, hey, and increase our count of number of islands. And in this way, like once we just need to traverse this whole 2D array once, and wherever we get a one, we just update our counter. And whenever we get a one, what we do is we filter out all the adjacent nodes and update their values. I'll write a pseudo code. I think I'll write the code for this. So let's say this is get number of islands. This is a function. And what we have is, let's say, yeah, 2D vector sort of thing. Vector. Oh, I'll keep it as int only. So just binary map. Okay, and what we finally need to figure out is we need to basically return the number of islands. Okay, so what we can do here is, I think the first step here is, let's just traverse this array one by one. We can use multiple flavors of iterating, like it's okay to use either of those. Few companies are very rigid about it, but I think it's your call. Okay, but what we are going to do is say we will just check, hey, if the current binary map I comma j is equal to this is equal to one, what we're going to do is we're going to return this. Yeah. So I think something similar. What we're going to do is if we find a one, that means we have found out a start of a island. And what we can do is we'll just increment this. But I think before incrementing, one of the most critical steps is we just have to update update the map 2D map that we have got. What this update function is supposed to do? look into all the connected parts of island and update their values. So yeah, I think I'll quickly write. This is nothing but a DFS sort of thing, where what we're going to do is it's a void operation that we're going to do. Like we're not going to do return anything. Uh, we could return something, but yeah, we'll go to that question later where we return what we are updating, so, sort of thing. Okay, I think the important part here is yep, we use this. And we have the start index, we have the ending index. I think few things that we need to take care of is defining the boundaries. Yeah, and something similar here. So what we're going to do is if so I think whenever we write any graph code, any traversal, it's really important for us to ensure that our boundary conditions are sorted. Boundary conditions, by boundary conditions I mean like when our this recursive array should close, otherwise we'll end up in the non-terminating loop and naked eye we won't be able to figure it out, and most of the interviews now we don't get a chance to actually compile them. We have to compile it and like technically compile it in our mind. So yeah, I think we'll just write if start is less than 0 or end is greater than the size of this. I think started does not make sense. It's X and Y. Yeah. Or X is or Y is less than 0 or Y is kind of equal to also makes sense because we are doing zero based indexing. So yeah. What we do is hey, we just say don't perform any action, just return. What we also do is we also check if this value present here x comma y is not equal to 0. So I think this part here is very critical. Like a lot of time this happens, we try to add this condition in the start. But always remember, we always have to check if the values present in the array are actually true or not. What will happen is that if x is less than 0, this if will go and it will return. But if we use this condition first, this will return an error. And like it looks like nothing, but we just have updated the way these mappings are. But at that we end up not writing good code, and it ends up giving an error. So yeah, and once we do this, the next step would be hey, let's update the binary map values. Binary map x, binary map y to 1, or maybe anything. Like I'm okay with any placeholder. You guys want to keep? I'll keep it maybe 0 itself. Okay. And then what we're going to do is we're going to perform the same action for its neighbors. Next, y, and it's something like this. Oh yeah. Basically, we are looking at the left, right, top, and bottom. All these 4 directions. Then just we return. I think this implementation, just remember, there's a way to do this implementation in a better way. I think this, I don't know how much value it adds in a, maybe while you're doing competitive coding or stuff, but it makes a lot code a lot cleaner if you do something like this. I'll just share it with you. So we have something like this vector pair, or maybe just a 2D vector. No, I think we'll keep a pair that makes it very simple. uh, indexes. And what we're going to do is this is going to contain -1, comma 0. Basically, all the all the numbers that we want to add to our x comma y, so that we can reach our neighbors. So it's going to be 0 comma -1. It's going to be 1 comma 0. It's going to be what 0 comma 1. And yeah, and what we can finally do is, instead of writing that same function, we just can write a simple for loop. I is less than indexes dot size, I plus plus, and that's yeah, that's pretty much it. That just we call this update map. You see how simplified the code becomes, and you just have to write x comma y plus indexes of I comma second, and something like this. So like first and second are something. This is a way we can look into the elements of a pair. So yeah. So if you look, what we have done is we have used a. This is a typically a DFS implementation. The implementation. Yeah. And I think even if you go with the BFS implementation, it would make much difference here, because we like our blocker is, as soon as we find a terminating event, we just stop. We are not stopping until we are traversing the list of all the elements, and and that's what helps here. So I think if you look at the complexity of this, this is fairly O of n, I mean n into m, where n is the size of basically n into m. N into m is nothing but the size of this matrix. And and I think the best part here is this question gives rise to a lot of new questions. Like one of the most basic questions that comes up is uh, not only find out the number of islands, but also uh, update those islands based upon some index. So what essentially means the first island would be 1, second island would be 2. Okay, I'll just write it in the next part. Something like this. The first element is going to be 1 island. The next island is going to be 2. The third island you find out is 3. The fourth island you find out is 4. And I think if you look at this, again, we can do this. What we need to do is we can in the this function. If we keep track of the current count, this number of island count, we started with 1, and if we keep track of this particular index, and what we do is we pass this placeholder also. That is nothing but say, hey, uh, int island number. And what happens is, where we were adding 0, we add this number. So we know how many times we have updated, like how many different islands are there. The next deviation of this problem again comes up saying, hey, we now need to find out what is the maximum size of island. So I think when I say size, something like this one particular consists of 8 ones. So we'll say the size is 8, and while size for this is 2. For this is also 2, and we have one size here. I think we again can modify our core code logic here. What we can do is, instead of this returning this update by function returning void, it can return integer. And integer is nothing but, I'll just quickly write. I'll tell you why these parts are important, because what happens is you'll get a tons of follow-up questions. So this is something that's prevalent in the interviewing world, that we try to tend to ask follow-up questions so that you don't have to start from scratch again. So something like this. So what you can do is say, convert this to int. If you're updating the value, maybe something like this. Initially count is 0, updated to 1, something like this. count is equal to count plus this, and then return count. So what happens here now is you have a clear idea of how many times you have updated the value, and again, like uh, you get that number, like what's the maximum count, and this what you can do is in the main function you can keep a function something like max size. Initially it's 0, and whenever you get a value int size from update map, you just validate if size is greater than max size. If that is so, simply we say hey, max size is equal to size, and we're done. So I think what we have done here is like we've tried to solve these two problems and multiple variations of it, and we looked into first few solutions that we could come up and how a simple problem could be extended to multiple other problems. And if you guys, I think there is another a lot. Again, like this is a standard format, and you'll see tons and tons of questions on this. Like there are variations where you don't need to connect. You need to find islands which are not connected to the boundary, but the whole crux is something similar. Trying to figure out, do an iteration, figure out what the cluster is, connection components are, and do some operation. Yeah. I think let me know, you guys, if you have any questions about this. So we'll move on to the third problem. So third problem is like fairly straightforward. It says, hey, given a particular string, divide it into two parts and ensure that number of distinct characters in P and Q are same. Something like this. What we are doing here is for this particular string, we can split it into two parts. First part is something like this: AA and CABA, and then is AAC and ABA, AAC and BA. And what we realize is only in the second and third case, the total number of unique characters in both of the cases are same. When I say unique characters, like assume capital A and small a to be same. So we could say unique, not unique characters, but maybe unique underscore characters or something like that. And we need to find out how many ways are there we can do this. So I think the problem is not only that finding out whether we can do it, how many times we can do it. And I think this, we'll look at a couple of different, I'll just again pause for a minute again, so that if you want to have a go at its solution, we'll go and then we'll start with the actual solution. Yeah. So I'll start with the, okay, yeah, I'll start with the solution. Solution part of it is like there are multiple ways, like tons and tons of ways I think we can do these questions. So I think the first way is, hey, let's find out, like break down the most the brute force way. Again, I emphasize on brute force because I think these problems are a bit not on hard side, and we might be able to justify the brute force very quickly, but in some cases brute force itself becomes complicated. So I think it's okay to have the first thought as a brute force. So I think the brute force approach that we can say is, hey, what we do, we look at all the possible combination, like we look at all the possible ways we can split, which is something like this. So basically, uh, we are splitting at index 1 I. And then what we do, we create a function, find exact find same unique count. And what we do, we pass the substrings from 0 to I, and sorry, 0 to I minus 1 and I to n minus 1. And what we do in this function is move on to the next page. What we do in this function is something very similar. We have string, let's say A, we have string B, and we traverse. I think what we'll do is we'll have a vector A count, which will just store, and this will basically store the occurrences of all the elements in A, and this will store for unique elements in B. We can use a set here also, but yeah, I think set also makes sense. Set makes more sense here. So that we can just update the value. We'll just insert the values into the set, and if the count becomes equal, we'll get the value. Because what happens in case of set, if you try to insert same value again, it won't accept it. And then we'll just do a quick iteration of this. A dot size I plus plus, and quickly we'll do something like this also for B dot size. And like the whole intent is again something same, like we just insert the values. Insert the values into E of I. There's something very similar to this. And then what we do, if it's something very simple, we say if A count dot size is equal to B count dot size, return, like we basically say if they're equal, return true, else false. And here what we are saying is if this is equal to true, then do nothing, just count plus plus. Like count plus plus is basically saying number of ways which we can divide our string into two parts so that both parts have equal number of unique characters. Count is equal to 0. And I think this is the most brute force way that we can come up with. Which again, if you see what we are doing, it's we are iterating it once, breaking it down into two parts, and then again iterating it again. For each number, we are creating two different. If you for each number, we are creating like a whole new set altogether again for each number, which again brings down its base complexity to n square also, which is this is way too brute solution. I think we need to improve again. Like we start with this, but we try to move from here to a better solution. And again, like if you see, like we try to see, hey, what are the steps that we are doing all over again, and is there a way we can not do those steps? And that's what when we start thinking and say, hey, I think uh, what if, just imagine something like this. This is the string a b a b b c a d b. Imagine we create a vector, or we store somehow number of characters till now. We store somehow the number of characters that are unique till now. So here we know there is a one character. We start from left and say it's still the one. Or for B, we say it's a second unique character, still two. We move to three and we say hey, it's still three. Now we are at fourth, and now we are at fourth. So this is something we can do in O of n. Now what we do is, yeah. What we do is we another so this is the I'll just write it down. We started this from left. Okay. Now what we do, we start from right and figure out what is the number of unique characters starting from the last index. From, let's say we start from A. It's 1 here. D, it becomes 2. It's still 2. Oh, for C, it's finally 3. A is still 3. B is still 3. Oh, okay, no, B becomes 4 and 4 and 4. If you remember, if you look at this, the total count will also always be same. because it's the same array we are traversing. It's just we are traversing it in a different direction. And this helps us a lot. So because now we know at each index what are unique characters to the left and what are to the right. And now what we need to do is simply do a very simple traversal. The traversal does something very simple. If this left array that we created, left of I minus 1 is equal to right of I, we just say count plus plus. Why? What we are saying is, let's say we are at I is equal to 2, this index. Left of it is I minus 1, and we say there is one character to the left of it. And at this current character, we know there are 4 characters to the right of it. And if these two values are ever equal, that means that number of characters to the left and right, unique characters, are always equal. So let's say in this use case, no, we don't have a use case such, but imagine if C would have been here. What would have happened? This would have been 3. And if we divide it into these two subparts, look at this, we get the answer. So we see the number at right of I is equal to left of I minus 1. Yeah, and I think if you look at this, how drastically we have decreased the complexity. We have added a space complexity of O of n again, but now we are able to do this in a single pass. Though this building also requires a single pass, but yeah. And I think the third point comes: is there a way to go better than this also? And there are ways via which we can go, and I'll just share a pseudo code for that. So what we can do ideally is we can try to find out a way that, let's say we find out first the total count, like the total number of unique characters. And then while we are moving forward, we remove the newly found characters, unique characters. If this newly found removed characters, if count of this is equal to remaining characters ka count, character count, we means that simply means that we have found our that index where if we divide it into two parts, the count is exact same. So yeah, I think this is I would encourage you guys to try this once at home. Like, these are like problems which have been asked really way too often, and I don't want you to miss out on the most optimal approaches. And yeah, I think something yeah, I think I'll try, I think that's all for this session, and I'll again try to spend a couple of minutes on just emphasizing what HiCounselor does. And I think again, like this is the perfect place for your job search. Like, they provide you the mentorship, the material, like how you want to move forward, and most of all, you don't have to pay anything upfront. So yeah, I think I would highly recommend this. And again, like, if you want some sort of coupon on that, feel free to use the referral code Tushar TUSHAR, and you get a $500 discount, which is a good amount. So yeah, that's pretty much it from my side. Yep. Any specific questions I'm open to? Yeah. Thanks a lot for being with me for an hour, and it was really nice. Thank you.